Show that the maximum rectangle that can be inscribed in a circle is a square. Let 2x and 2y. So if you see, this is 2x and 2y with the sides of the rectangle, and r be the radius of the circle. Then, so from this diagram, if you see, if you take this as 2x, so this will become x from the center to this point, and this is y we are taking. And if you see, this is r, so from simple Pythagoras theorem we can write x square plus y square is equals to r square. Side square plus side square is equals to hypotenuse square. So r you can write from this, y is equals to, if you send this is r square minus x square, and y is equals to under root of r square minus x square. So let us take this as equation number 1. So let a be the area of the rectangle, then a will be, so if you take we know simple formula, area of rectangle is length into breadth. Length will be 2x and breadth will be 2y. So it is 4xy, and once again it is 4x. In the place of y we can write under root of r square minus x square by using this equation. So finally you can write area as 4x into under root of r square minus x square. So to find out maximum of any function, we'll find out first of all first derivative, and we'll equate that to 0 to get maximum or minimum. From that we'll find out roots, and once again we'll find out second derivative, and we'll see for any particular root, if that is less than 0, we'll get maximum value of function for that value. So here also we are going to the same thing, do the same thing. So this is a area. So we are differentiating this with respect to x, because x is a variable here in this equation, and we know r will be the constant. So why it is constant means, so in a particular circle we are finding out how much rectangle, means maximum rectangle area we can inscribe r. We are showing that maximum rectangle that can be inscribed in a circle is a square. So here square, the circle is fixed, means the radius is fixed, means you can say that radius is a constant in this case. So the only variable is x here. And if you see, if you differentiate with respect to x, 4 is a constant, and this is in the form of uv. We know differentiation of uv is nothing but, suppose if you take this x as u and this as v, so we know formula for uv differentiation is u into differentiation of v, means x into differentiation of this. So this is in the form of root x. We know differentiation of root x is 1 by 2 root x, and in the place of x we have r square minus x square. So we know r is constant here, so it is 0 minus x square differentiation is 2x, and plus, so u into differentiation of v plus v into differentiation of u. So differentiation of x with respect to x is 1, and when you simplify in the next step, it is minus 2x square, and we are taking LCM here by 2 into under root of r square minus x square. So if you take LCM, so here you will get minus 2x square, plus here you will get here 1 is there, so 1 into 2 under root of r square x square you will get here, and once again this term is there under root of r square minus x square. So when you simplify in the next step, minus 2x square plus it is root x into root x, nothing but x. So that is nothing but under root of r square minus x square under root of r square minus x square. You get only, means when you multiply here you get r square minus x square, and once again when you simplify in the next step, it is minus 2x square plus it is 2r square plus into minus minus, and 2x square by 2 into under root of r square minus x square. So when you just take 2 common here, and you can cancel here, and the remaining things will be r square minus x square minus x square. You can write as r square minus 2x square, and by r square minus x square, and 4 is there. So this is a dA by dx value. For a should be maximum, so this dA by dx should be 0, means when equate to 0 we'll get here. So when this is equated to 0 we'll get r square. So if this is equated to 0, this will be 0, and you can write r square minus 2x square is equals to 0. From that you can write x is equals to r by root 2. So if you send this side, r square is equals to 2x square, and write only x r square by 2 under root. So x is r by under root 2. So once again, if you write dA by dx here, 4 into writing this inside, so r square minus 2x square by under root of r square minus x square. Once again you are differentiating this with respect to x, so it is d square a by dx square. So once this is in the form of u by v. We know differentiation of u by v is as v into differentiation of u minus u into differentiation of v by v square. So if you see, this is u numerator, v denominator. So v means this one under root of r square minus x square, and differentiation of this r is constant, so whose differentiation is 0, minus 2 into x square is 2x, so 2 into 2 4, and minus is there, so minus 4x minus v into differentiation of u minus u into means r square minus 2x square into differentiation of v is differentiation of under root of r square minus x square. So it is, if you take it as root x, differentiation of root x is 1 by 2 root x, and in the place of x we have r square minus x square. So here you will get here 0, and it is x square means 2x, and minus is there, so minus 2x by v square means under root of r square minus x square whole square. So square under root goes, and only r square minus x square will be remaining. And here when x is equals to r by root 2, the value of d square by d square a by dx square is so when you substitute in the place of x r by root 2, so under root of r square minus, here if you substitute r by root 2 whole square means r square by 2 you will get, and minus 4 into here r by root 2, and if you see for the second term, it is r square minus 2 into r by root 2 whole square is r square by 2. So 2 cancels, and here r square, so r square will be 0, means this total second term will be 0. So we are not writing here, and when you simplify this term, it is r square minus r square by 2 is r square by 2, but it is under root. So in the numerator, under root of r square means square, and root goes, and so it is r, and denominator will get square root 2 minus 4 into r into root 2 by, here you will get r square by 2. So root 2 into root 2 is 2. So this 2 goes cancel, and r into r square goes. So we'll get 4 into minus 4 is minus 16. So the value of d square a by dx square for x, for this value is minus 16, which is negative value, which is less than 0. So a is maximum for this value, that is x is equals to r by root 2. So if x is equals to r by root 2, we have written y is equals to under root of r square minus x square. So r square minus x value is r by root 2 whole square means r square by 2, and you are getting y is r by root 2 once again. So x and y values are same. So hence the sides, these are x and y values are half values of the sides. So when you write total length and breadth, it will be 2 into x and 2 into y. So 2 into r by root 2 and 2 into r by root r, that is, you can write 2 by root 2 is root 2. So root 2 r and root 2 r. So when you get x and length and breadth as same, we know that is a square. So the maximum rectangle that can be inserted in a circle is a square, hence it is proved here. So for more videos, please subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.